Next, we're going to discuss cardiovascular regulation. Neural components of perfusion homeostasis are somewhat regulated by the autonomic nervous system. Autonomic means automatic. You don't control your autonomic nervous system, you do control your voluntary nervous system. So the autonomic nervous system is made up of the sympathetic nervous system and the parasympathetic nervous system. Sympathetic nervous system is our flight or fight. It gets triggered during times of anger, fear, and pain. The sympathetic nervous system gets triggered when you need your muscles to run away from a threat. So now your blood will get routed into your muscles. So sympathetic stimulation increases vasoconstriction, so blood and oxygen can get to vital organs. Increased heart rate, increased blood pressure, and open airways. The parasympathetic nervous system is the opposite. It is triggered during rest and digest. It lowers the heart rate, and it routes blood away from the muscles into the GI tract during restful activity. Baroreceptors communicate with the brain. They are located in the aortic arch, and they're sensitive to stretch or pressure within the arterial system. Baroreceptors stimulate the parasympathetic nervous system to decrease the heart rate and vasodilate the peripheral blood vessels when blood pressure is too high. When blood pressure falls too low, they activate the sympathetic nervous system to cause increased heart rate and blood pressure. Chemoreceptors are located in the aortic arch. They are stimulated by increased arterial carbon dioxide, and they are also stimulated by decreased arterial oxygen. The chemoreceptors stimulate the brain to increase cardiac activity, and they initiate changes in the heart rate and the arterial pressure. Why does this happen? Well, if the body is too high in carbon dioxide, the heart works harder to pump the blood and rid the body of CO2. Likewise, if the oxygen level is too low, the heart will work harder to increase the oxygen in our blood. The endocrine system also plays a role in regulation of blood pressure. Next, we're going to talk about the renin-angiotensin-aldosterone system. Renin is an enzyme that is secreted by the kidneys. It converts angiotensinogen to angiotensin 1. Next, an enzyme called angiotensin converting enzyme converts angiotensin 1 to angiotensin 2. Here we can see a schematic. Renin is released from the kidneys. This allows angiotensinogen to convert to angiotensin 1. Next, the angiotensin converting enzyme allows the angiotensinogen 1 to convert into angiotensin 2. Angiotensin 2 is a potent vasoconstrictor. Vasoconstrictor meaning that the blood vessels are constricting. Angiotensin 2 increases vascular resistance and causes resistance to blood flow. It also increases blood pressure. We're going to talk about the kidneys as well and what their role is in the regulation of blood pressure. Many substances cannot pass through the filters and remain in the blood. The kidneys contain millions of microscopic filtering units called nephrons, which are the working components of the kidneys. The kidneys help regulate the balance of sodium and water in the body. Kidneys excrete water-soluble waste substances, sodium and water. Many substances pass through the filters, like sodium and glucose, but are reabsorbed back into the blood. Angiotensin II, triggered by the release of renin, signals the adrenal glands to secrete a hormone called aldosterone. This hormone signals the kidneys to retain sodium and water. When the kidneys retain sodium and water, there is an increase in the blood volume, which causes increased blood pressure. Antidiuretic hormone is another player in the regulation of blood pressure. Antidiuretic hormone is also called vasopressin. It is secreted by the brain in response to low blood pressure. It acts on the kidneys to retain water, and the result is to increase the blood pressure. Here we see the pituitary gland. It is in the posterior pituitary gland that antidiuretic hormone is stored. This picture represents all the different systems that control blood pressure. As blood is pumped through the arteries, it creates pressure within the wall of the arteries. As blood is pumped through the arteries, it creates pressure within the wall of the arteries. As the heart contracts, this increased pressure is called the systolic pressure. As the heart contracts, the increased pressure is called the systolic pressure. As the heart relaxes and fills, this decreased pressure is called the diastolic pressure. So here we see the heart relaxing. This decreases pressure and is called the diastolic pressure. Hypertension is high blood pressure. Hypertension is measured by consistent elevation in blood pressure, either greater than 140 systolic or greater than 90 diastolic. Remember, normal blood pressure is around 120 over 80 millimeters of mercury or less.